Hello, Tanushri. We can start.
Hello, am I audible?
Yes, yes, yes.
Okay. Yes, Pritam. Okay, so let us begin with our test today regarding the topic of chromatography. So we will attempt each question and try to scheme or समझने की कोशिश करेंगे कि how we will be attempting the answers and which possible options are close to the correct ones and how to eliminate options and attempt the test. So our very first question is headspace analysis is carried out in order to option A, analyze volatile compounds from solid or liquid samples. Option B, determine the psychological state of the tutor. Option C is analyze the column contents ahead of the sample. And option D is to determine non-volatiles. Just a second, I'll put my laser on so that, okay. So as the question states that headspace analysis is a part of gas chromatography, that is GC. So gas chromatography में क्या होता है? Basically, there are two types where you're going to incorporate a column. So we will call it as the gas liquid chromatography, and in certain cases, you can analyze your volatile samples directly using gas chromatography. And how will you do it? You can do it by using the headspace analysis. So headspace analysis, ये word जो कहता है, it is very simple to understand. You are going to place your sample in a vial, and since your compound is volatile, the vial will get saturated with the vapors of your sample. So once the vial is saturated with the vapors of the sample, since the vial is half filled, the remaining half portion of the vial is saturated with your sample vapors. तो अभी क्या होता है? Because the vial is saturated with the sample vapors, it is easy to inject the gaseous vapors directly into your gas chromatography system. तो headspace analysis में वही होता है, head के ऊपर जो स्पेस है जहाँ पे तुम्हारे कंपाउंड्स वोलेटाइल कंपाउंड्स के वेपर सैचुरेटेड है, वो वेपर को डायरेक्टली सिस्टम में इंजेक्ट कर सकते हैं एंड वी कैन एनालाइज यूजिंग द गैस क्रोमैटोग्राफी टेक्निक. So based on that, because the sample is in the form of a gas, they are easily analyzed as they are separated from the column and they can give you the results. So the option A is your possible answer. Option B cannot be your answer because it is not related to psychology. So it cannot determine the psychological state of the tutor. Also, option C cannot be the answer because it is not used to analyze the column contents ahead of the sample. You will analyze the column contents ahead of the sample when you have to employ a guard column. So column contents sample के पहले हम कब analyze करेंगे? When we have to protect our sample or get uninterrupted results. So in that case, you are going to incorporate a guard column, and guard column will block away the unnecessary compounds which are not required in the analysis, and pure sample will be filtered out of the guard column, and then that sample will be analyzed in the analytical column. So option C is also not the answer, and it cannot be to determine non-volatiles. Why? Because since it is non-volatile in nature, there are not going to be any gaseous vapors produced. So there will not be any headspace generated. So because headspace is not going to be generated, it cannot be used for headspace analysis, that is non-volatile compounds. So हम non-volatile compounds को भी headspace analysis नहीं use कर सकते. So your option is answer A. So I'll click on the correct answer and I will proceed. Next question, which of these effects result from slow injection of a large volume of sample? Option A is increased resolution. Option B is decreased resolution. Option C is non-linear detector response. And option D is constant resolution. Now, what happens in liquid chromatography or HPLC or any other type of chromatography? क्या होता है कि when we are going to inject a small volume of sample, now our analytical column and our chromatographic technique is sensitive enough to detect and quantify and your sample. So unnecessarily bombarding the column with a heavy concentrated sample is not required. So in such cases where you usually prepare low concentration samples, and these low concentration samples are usually prepared in the nanogram, picogram or microgram range, and then they are injected into your column. बहुत ज़्यादा highly concentrated अगर sample रहेगा, so there is a chance that your analyte will not be properly separated because the quantity of your sample is way too much for the minimal quantity of mobile phase to accurately separate it. So because the amount of sample is comparatively much more to that of your mobile phase, तो ऐसा होगा कि जैसे कि you are mixing too much sugar in water. If you will mix too much sugar in water, you will get a thick syrup. But if you want to make a mildly sweetened solution, you will require less sugar. So that is the issue. So the column may get blocked because of unnecessary loading of sample, which is undesired. And because if highly large volume of sample is injected in your column, even if the concentration is less, like suppose you are preparing a solution with a low concentration, like I will only inject how much of volume is required. Like I may inject 50 microliter or I may inject 100 microliter of sample. Unnecessary 1 ml of sample I will not inject into the column, because usually the mobile phase flow rate which is maintained in the column is 1 ml. तो अगर 1 ml मेरा मोबाइल फेस जा रहा है और अननेसेसरी मैं सैंपल का भी 500 ml उसमें इनकॉर्पोरेट कर रही हूँ, तो सैंपल सेपरेशन को प्रॉब्लम होगा. So obviously increased resolution will not occur. Why? Because increased resolution means the two peaks or different peaks of an analyte or even a single peak of an analyte is well separated, gives you a proper peak shake without tailing and without a peak broadening. तो resolution बहुत अच्छा achieve तभी होगा when you are using a minimal injection volume or when you are using low concentration sample. So increased resolution is not a possibility in this case. Second option, decreased resolution, is highly possible. Why? Obviously, you will get a very broad peak. It may also generate split peaks, and the peak may not be well defined or well separated. So decreased resolution is one of the reasons. It will not give you a non-linear detector response. Why? Because linearity is governed through an entire calibration curve range. So even if you are injecting large volume of sample, although the concentration will still remain the same, because only the volume is higher, the concentration will again remain the same. So it will not give you a proper peak shake, but the linearity of the method will be maintained if the method is developed properly. So non-linear detector response is not your answer. Constant resolution is also not the case. Why? Because if an initial analysis has been done on the same analyte, then maybe that analysis was done in a good way, the analyst was good, and the resolution that was achieved was also very good, and you get a very sharp peak. Maybe next time when a second analyst or a second person is employing the same method of analysis and conducting the experiment, if he or she is not injecting the volume of sample properly, and instead of the designated volume, अगर वो ज़्यादा volume of sample inject कर रहा है, तो you will never get consistent or constant results. So maybe on day one you achieved a very good peak shake, but because of the error of the analyst, you might get a very broad peak shake or a very badly resolved peak. So constant resolution is also not the answer. Constant resolution will only be obtained if the consistent volume of injection of sample is maintained throughout the analysis, intraday or intraday. So option B is also not your answer. So your possible answer is option B. So let us proceed with the next. Which of the following column can be used for gas solid chromatography? Now, what is a gas solid chromatography? Basically, in a gas solid chromatography, you have a gaseous mobile phase and you have a solid stationary phase. So analytical column is used for HPLC. Option 1 is open tubular column. So open tubular column is one of the specific columns that you use for gas chromatography. So open tubular column is the answer, because an open tubular column basically is a column of a tubular shape and which has a stationary phase, which has a solid which is coated maybe with a liquid. If it is coated with a liquid, it will be called as a gas liquid chromatography. And if it is not coated with a liquid and it is just a solid stationary phase, then it will be called as a gas solid chromatography. So you use an open tubular column for gas chromatography. Analytical column is a simple column which you will use for your HPLC. So analytical column is basically any column that is helping you separate your analyte. So analytical column cannot be used for gas solid chromatography because the stationary phase is rigid and is strictly solid. And to separate analytes in your analytical column, you need a liquid mobile phase, which is not the criteria in this case because it is clearly specified that the technique is gas chromatography. It can also not be a separation column because an analytical column and a separation column are basically the same thing with just different terminologies. So separation column is also a column which helps in separate your sample, maybe qualitatively or quantitatively. So also again, a separation column requires a liquid mobile phase, so it cannot be your answer. Guard column is basically a column which is used preliminary to your analysis to protect your sample or to protect your chromatographic technique. So usually if there are any other impurities that need to be separated or is not desired in the analysis, they will first be trapped in your guard column, and then a pure form of the sample will then be directed to your analytical column. So a guard column cannot be used for either gas solid chromatography also, because a guard column is not incorporated for GC, that is gas chromatography. So my answer is obviously the very obvious, which is the only column which is from all of these options stated here, which is exclusively used for gas solid chromatography, that is open tubular column. Let's move on to the next. The general expression for the appearance of a solute in an effluent is where V is the elution volume of a substance, V0 is the void volume, and Kd is the distribution constant, and Vi is the internal water volume. Now, if you students must remembering, this is a part of a what you say gel exclusion chromatography. So void volume and total volume में क्या होता है? So basically you have the four options, that is V, that is total volume, equals to V0, that is the void volume plus the distribution constant plus internal volume, internal water volume. Second option is V equals to void volume divided by the internal water volume. Third option is total volume equals to the void volume minus the distribution constant into the internal volume of the water. And the fourth option is V, that is the total volume divided by the void volume equals to the distribution constant multiplied by the internal water volume. So void volume equals to the volume of water solvent, that is the solvent surrounding the gel bead when you are talking in terms of the gel exclusion chromatography. So that is why it is called as V0, that is the void volume. Now the volume of the solvent inside the gel, that is the inner volume, that is VI, internal water volume, that is the solvent which is present inside your gel stationary phase. And the effluent, that is the elution volume. The effluent is also called as the elution volume, that is the volume of buffer required to elute any substance is called as the elution volume. So that is the capital V which is there in all of these options. Is totally and entirely dependent on all the three factors. क्यों? क्योंकि उसको void volume की भी जरूरत पड़ेगी, क्योंकि जब तुम तुम्हारा बफर नहीं डाल रहे हो तो भी तुम्हारे स्टेशनरी फेसेस के बीच में जब अरेंजमेंट होगा तो उसका void volume is important. Secondly, the internal water volume is also important because since it is a gel, there is water enclosed in those beads, so that factor also has to be considered. And distribution constant, that is the distribution constant is the major factor. Q, because there is a partitioning which is going to occur among the buffer which you are going to add and the gel beads. So basically जब तुम analyte डालोगे और जब तुम तुम्हारे buffer solution डालोगे, so the analyte will interact with your gel beads, that is your stationary phase, and because of the partition coefficient, they will distribute accordingly and you will get your retention time. So all these three options stated below are not the correct expression or not the correct derivation for this, because the total, that is the effluent volume, is dependent on both the void volume, the distribution constant, as well as the internal water volume. So division or subtraction is not possible for all of these variables, because these variables all add up to this entire equation. So your answer is option A. Let's move on to the next question. In which chromatography method is the stationary phase more non-polar than the mobile phase? Now, in which of the chromatography method is the stationary phase more non-polar? We have option 1, ion exchange chromatography. We have normal phase chromatography, C, reverse phase chromatography, and size exclusion chromatography. Let's move on how we will eliminate the options. Ion exchange chromatography nahi ho sakta, kyun? Because the mechanism of separation in ion exchange chromatography is exchange of the ions. तो यहाँ पे जहाँ exchange involved है, तो stationary phase can either be polar or non-polar. So it is not strictly necessary कि the stationary phase has to be non-polar in case of ion exchange chromatography. So this option of mine is going to be eliminated. Next option is normal phase chromatography. As the name suggests, in normal phase chromatography, we have a polar stationary phase. And in reversed phase chromatography, which is our third option, we have a non-polar stationary phase and a polar mobile phase. So normal phase chromatography is not our answer. क्यों? क्योंकि stationary phase तो हमारा polar होता है normal phase में. तो इसीलिए normal phase chromatography is not our answer. रही बात size exclusion chromatography की, as the name suggests, the chromatographic separation is based upon the size. So different sized molecules are separated differently. Smaller molecules will leave the column faster compared to the larger molecules, since they will face hindrance. So size exclusion chromatography is also not incorporating a non-polar stationary phase, because the separation is based on the size, that is a sieving technique. So our only possible option is third, that is reverse phase chromatography. क्यों? क्योंकि reverse phase chromatography में ही we have a non-polar stationary phase and a polar mobile phase. इसीलिए reverse phase chromatography में we have these silica columns. We have the multiple chaining of this carbon in silica columns. We have the C18 column, we have the C8 column. So we have, that is the reason why reverse phase chromatography में we have a non-polar stationary phase. So answer is reverse phase chromatography. Moving on to the next, which type of mechanism is applicable to chromatography? Option 1 है absorption and desorption. Second option is absorption and adsorption. Third option is adsorption and desorption. And fourth option is absorption and diffusion. पहला बात तो क्रोमेटोग्राफी में क्या होता है, देयर इज अ पार्टीशनिंग इफेक्ट गोइंग ऑन एंड डिपेंडिंग अपॉन द एफिनिटी. अगर मोबाइल फेज के लिए ज्यादा एफिनिटी है तो मोबाइल फेज के साथ पहले जल्दी ल्यूट होगा, और अगर स्टेशनरी फेज के लिए ज्यादा एफिनिटी है तो वो स्टेशनरी फेज पे ज्यादा टाइम एनालाइट विल स्टे. So the staying mechanism with the mobile phase or the stationary phase is basically because of the phenomena of adsorption. Absorption नहीं होगा because no stationary phase will absorb your analyte, because if any stationary phase is absorbing your analyte, then it is very difficult to deabsorb your sample and remove the sample out of the column. So absorption and desorption is not your answer. Second is absorption and adsorption. Both the phenomena of absorption and adsorption, that is adsorption means adherence on the surface and absorption means adherence within the surface. So absorption and adsorption दोनों नहीं होगा. So B option is also eliminated. Now I have the remaining two options जो है adsorption and desorption and absorption and diffusion. So absorption भी नहीं हो रहा है तो this option is not applicable because absorption phenomena chromatography में होता ही नहीं. So you will eliminate D option again. So diffusion may sometimes occur, but it is not always the case. So absorption and diffusion is not your answer. So the only possible answer is adsorption and desorption. So now I will tell you why is it adsorption and desorption. पहली बात तो एनालाइट क्या होता है, सरफेस पे अटैच होता है, दैट इज एडसॉर्ब होता है. फिर अभी वो एनालाइट जब तुम्हारे स्टेशनरी फेस पे ट्रैप होता है, that is the time it takes to trap on the stationary phase will be your retention time. अभी तुमको अगर उसको कॉलम के बाहर इल्यूट करना है, निकालना है उसको कॉलम के बाहर, तो तुम एक ऐसा मोबाइल फेस यूज करोगे जिसके लिए अफिनिटी एनालाइट की ज्यादा होगी। तो जस्ट बिकॉज अफिनिटी फॉर, पहले तो अफिनिटी स्टेशनरी फेस के लिए था इसलिए वो स्टेशनरी फेस पे एब्जॉर्ब हुआ। नाउ तुम ऐसा मोबाइल फेस डाल रहे हो जिसके लिए उसका अफिनिटी बढ़ रहा है, तो मोबाइल फेस के लिए जब उसकी अफिनिटी बढ़ जाएगी, so it will desorb, that is detach from the surface of the stationary phase and then move along with the flow of the mobile phase. So adsorption and desorption is the basic phenomena or mechanism which is applicable to chromatography. So that is our option C. Moving on to the next. Which force is at work in chromatography? Option A is hydrogen bonding, option B is London force, and option C is electrostatic force. So since chromatography involves all the techniques, that is, we have our size exclusion chromatography, we have the liquid chromatography, we have the gas chromatography, where we have the ion exchange chromatography. So hydrogen bonding is zaruri hai, because the adsorption phenomena will also depend upon how strongly the hydrogen bonds are being formed for the between the analyte and the stationary phase. The London forces are also important. Electrostatic forces will also be a governing factor when you are doing ion exchange or ion pairing chromatography. So which force is applicable in chromatography? The option is all of the above, because hydrogen bonding, London forces as well as electrostatic force helps the analyte for binding onto the stationary phase, and these are all the important factors which govern the separation of your analyte. So the answer is all of the above. Moving on to the next. The quantitative analysis is done using ion exchange chromatography, thin layer chromatography, gas chromatography, and liquid chromatography. So the answer is ion exchange chromatography में क्या होता है? We are going to analyze our sample based on the ion exchanging mechanism. So how much ions are being exchanged, or how much of it is being bonded or exchanged with the phase, it is a very qualitative kind of an analysis. So ion exchange chromatography will never give you the exact concentration of how much samples is present unless you are using a mass detector attached to it. So if your ion exchange chromatography will only be capable of quantifying your sample rather than qualitative analysis if it is coupled or hyphenated with a mass detector or any other detector which is capable for quantifying your sample. So ICMS, that is ion exchange or ion chromatography MS, is a hyphenated technique where ion chromatography is coupled with your mass detector. So only in ICMS will your technique be able to quantify your analyte. So this is just a simple ion exchange chromatography. So ion exchange chromatography will strictly do a qualitative analysis rather than a more specific quantitative analysis. Thin layer chromatography, again in TLC you get spots. So until unless the spots, how will you identify the spots? TLC में जो spots आते हैं, you will use different reagents to produce a color under the UV light, or you will spray some reagents which will give the color, like maybe you will use iodine fumes, or you will spray ninhydrin for proteinaceous samples. So again, thin layer chromatography becomes a qualitative technique. A thin layer chromatography will become a quantitative technique only when you are going to use a high performance thin layer chromatography, that is HPTLC. So in HPTLC, the bandwidths and everything are calculated by an instrument and a detector, and they will give you the exact concentration of the sample applied. So thin layer chromatography alone will not give you a quantitative analysis, but it will give you a qualitative analysis. Next, again, you have gas chromatography. Gas chromatography is the only technique which directly calculates the amount of sample injected into your gaseous phase. So gas chromatography is the technique which is analyzed by quantitative analysis. Liquid chromatography again will give you a separated peak. But to identify the peak and to find the concentration of the sample, you will again need a detector. So maybe you will use a UV detector or a refractive index detector, or maybe a mass detector. So liquid chromatography alone is only capable of separation, but high performance liquid chromatography, which involves the use of a detector, can do quantitative analysis. Now, since the option is not specifying HPLC or ICMS or high performance TLC, so the only option which is capable for quantitative analysis that remains among all four is our gas chromatography. So let us proceed with the gas chromatography as our answer. So this is how I have eliminated the remaining three options. What is Cefadex? Cefadex क्या है? We have four options. It is a Kessel board, or is it a cross-linked dextrane, or is it a polyvinyl acetate, or is it polyvinyl pyrrolidone? Secondly, Cefadex is a name of a cross-linked dextran. तो वो Kessel board भी नहीं है, nor is its chemistry similar to that of polyvinyl acetate, nor is it polyvinyl pyrrolidone. So these are not polymers. So Cefadex is basically a cross-linked dextran. So dextran is the basic parent chain in Cefadex. So Cefadex answer is cross-linked dextran. So this was a very theoretical question. Next, what is the advantage of HPLC? Option A is improved data processing capabilities. Option B is use of pre-coated plate with stationary phase particle size less than 10 micrometer in diameter. Option C is auto sampler, and option D is all above the above. Now we are talking in terms of the high performance liquid chromatography. So basically high performance liquid chromatography में क्या होता है? High performance means what? You are going to use columns which have a very less particle size so that you can get defined resolution and more accurate and sensitive separations. Also high pressure में क्या होता है? You are going to use a high pressure flow of your mobile phase. And also HPLC has an auto sampler. क्यों? यूजुअली क्या होता है, इन ट्रेडिशनल टेक्निक्स ऑफ लिक्विड क्रोमेटोग्राफी मैनुअली इंजेक्ट करना पड़ता था सैंपल, लेकिन अभी ऑटो सैम्पलर है तो क्या होता है, द इंस्ट्रूमेंट इटसेल्फ यू हैव प्रोग्राम बना के तुम अपने कंप्यूटर पे उसको फीड करते हो, एंड बेस्ड ऑन दैट प्रोग्राम द सिस्टम ऑटोमेटिकली टेक्स द इंजेक्शन फ्रॉम द रिस्पेक्टिव वाइल्स. तो इसीलिए ऑटो सैम्पलर इज वन ऑफ द बेसिक एडवांटेजेस ऑफ HPLC, and also you can keep multiple samples in your auto sampler and it eliminates the manual effort of injecting the samples repeatedly again and again. So auto sampler is one of the advantage. Improved data processing capabilities, obviously why? Because you have the software where you're going to attach it along with your liquid chromatography technique. So the software has all the programs and systems set in it, so it will give you the chromatogram, it will produce the chromatogram, it will give you the area of the chromatogram. Also the detector response will give you the concentration of the sample that has been analyzed or separated. So obviously improved data processing capabilities तो है ही, इसीलिए नाम भी है उसका high pressure or high performance liquid chromatography. And use of pre-coated plates, as I said, the smaller the particle size of the stationary phase, greater will be your separation and better will be your resolution, because everything, that is the number of theoretical plates and everything are considered, and it will give you better separation. So the option answer is all of the above. So all of these three above options are advantages of HPLC. So my answer is option D. Let us move on to the next. In chromatography, compound X has a retention time of 10.5 minutes and peak width is 0.7 minutes, and compound Y has a retention time 15.5 minutes and a peak width is 0.4 minutes. Then what will be the resolution? You have four options: 9.09, 0.909, 4.54 and 5.5. So there is a formula to solve this problem. So I will solve it using the whiteboard. So you can see as the formula states. So resolution ka formula, as you may have all studied in your, it is RS equals to, just a second, 2 times the retention time of compound 2 minus the retention time of compound 1 divided by the width of compound 2 plus the width of compound 1 plus the width of compound 2. Now what? Now we will substitute the values. What is the retention time of our second compound? It is 15.5 minus retention time of the first compound, which is 10.5, divided by what is the width of our first compound? It is 0.7. And what is the width of our second compound? It is 0.4. So if we solve this, 15.5 minus 10.5 is 5. The 5 multiplied by 2 is 10. So we have 10 in the numerator. And in the denominator, we have 0.7 plus 0.4, which is 1.1. So if you divide 10 by 1.1, your answer is 9.09. So it is a very practical approach. तो इसको directly ऐसे type के questions को तुम directly formula लगा के solve करोगे. So I hope you will be able to solve this. So before approaching all these questions, you have to be thorough with all the formulas and the equations of your chromatography, because कभी-कभी ऐसे questions आएंगे. So these options will be totally directly answerable. क्योंकि जो correct answer है वही तुम्हारा option होगा. There are no other options which are closely going to be related. So such type of questions are very easy to solve. So our resolution is 9.09. So let us get back to our test. So I will go with option 9.09. 0.909 हमारा answer नहीं है, as we have calculated already. 4.54 is also not our answer. 5.5 is also not our answer. So we will save and proceed. Coloring agent used in chromatography is known as which of the following? Methyl orange, phenolphthalein, ninhydrin और apple. कौन से तुम coloring agents chromatography में use करोगे? Option A, methyl orange नहीं है, because methyl orange is used for titrations. Phenolphthalein is also used as an indicator in titrations. But ninhydrin is a coloring agent used in chromatography. Why? Because when you're having protein samples or samples which are rich in amino acids, so they can be analyzed in TLC or paper chromatography simply by spraying with ninhydrin. तो क्या होता है, जैसे ही तुम्हारा TLC या paper chromatography में you get a spot or the distance traveled by the solute because of the aid of the mobile phase, तो वो distance जो है जो तुम्हारे paper chromatography या TLC plate में travel होता है, so applying the suitable formula, so we can find out the retention time of the sample. तो वो spot कभी-कभी invisible होता है and we will not be able to see it until and unless they are a fluorescence compound which can be subjected to the UV rays, or if they are sprayed with some type of coloring agent. So ninhydrin is the only agent along. There are other agents also, like we have iodine fumes, and if there are samples which will make a complex with iodine. So then if you spray iodine, you will get a blue spot. So if iodine is if iodine fumes are subjected to your plate, then you will get a colored spot. Then sometimes you might also get a colored spot by charring your samples with sulfuric acid. So if you're going to use H2SO4, so the sample will get charged and it will give you a blackish brownish spot on your paper chromatography or TLC plate. So phenolphthalein is phenolphthalein is not your answer. So ninhydrin जो ऐसा reagent है जिसको अगर तुम spray करोगे तुम्हारे TLC या paper chromatography के plate पे, it will react with the amino acids present in the sample and will give you a purple or blue or dark violet colored spot. So ninhydrin is the coloring agent used in chromatography. So let us save and proceed with our next question. Now in column chromatography, the stationary phase is made of dash and the mobile phase is made of dash. Option is solid liquid, B is liquid liquid, option C is liquid gas, and option D is solid gas. Now let us proceed with all of the options. I will say my answer is solid liquid. क्यों? क्योंकि column chromatography में stationary phase solid होता है and mobile phase has to be a liquid. Why? Because when mobile phase को तुम्हारे stationary phase के through डाला जाएगा, तो based on the affinity कि उसको mobile phase के लिए ज़्यादा affinity है या तुम्हारे stationary phase के लिए ज़्यादा affinity है, उसके basis पे your analyte will be separated from the column. So I will say my answer is solid and liquid. Now, why is it not liquid and liquid? Obviously, because if I'm mixing two liquids, there is no separation going to occur. अगर मेरा stationary phase भी liquid है, mobile phase भी liquid है, और मैंने sample दोनों liquid में डाल दिया, तो separation तो possible नहीं है. So option B is eliminated. Option C, it cannot be liquid gas. Why? Because it is not gas chromatography. The only scenario where your stationary phase can be liquid and your mobile phase can be gas, that is your gas chromatography, because you are going to have the liquid coated column. So liquid coated column and a gaseous carrier mobile phase is going to be used in gas chromatography. The question is not related to gas chromatography, it is related to column chromatography. So option C हमारा आंसर नहीं है. Option D, it cannot be solid and gas because there cannot be equilibration again in column chromatography between a solid and gas. क्योंकि column में अगर तुम gaseous mobile phase incorporate करोगे, so the gaseous mobile phase will not be properly what you say equilibrated in the column, because why? The stationary phase is packed with a solid substance, so it cannot be a solid gas. क्योंकि column chromatography में if you are having a solid stationary phase, you will require the flow of a mobile phase to be sample. So a solid gas, a solid stationary phase and a gaseous mobile phase is only going to be possible in terms of, again, if you are talking in terms of gas chromatography. Why? Because in gas chromatography we have special columns which have a solid stationary phase coated with a liquid or a waxy material, and then you have the carrier gas in it. So again, since the question is not related to GC, so option D is also not our answer. So our answer is the solid and liquid. That is option A. So let us proceed. Now, in GC, capillary columns are coiled using which material? अभी GC मतलब गैस क्रोमेटोग्राफी. तो गैस क्रोमेटोग्राफी कैपिलरी कॉलम्स में जो कॉइलिंग मटेरियल है वो क्या होता है? As I said, capillary columns in GC are coated with a liquid waxy material. So that, why is it waxy? So that it adheres adequately along the diameter and the internal circumference of the column. बाकी अगर तुम liquids use करोगे, so they will not uniformly coat your column. So you only need a coating material, and as we all know, to coat anything, be it maybe your nail paint, that is when you're going to coat your nails with a nail polish, or if you're going to use a coating for your tablet, or if you're going to use a coating for any of your formulation, that is if you're using a face mask, that will also require waxy polymers. So these polymers are required for giving the internal coating for the column. So it is not polyethylene. Why? Because polyethylene is not a waxy polymer. It is quite viscous in nature. It is not polypropylene, because polypropylene is also falls in the category of polyethylene. So again, this polymer is not going to be your answer. Then again, you have the polyether. So polyether is also a very liquidy kind of a polymer. So that will again not uniformly coat the internal walls or the diameters of your column. So what remains, the possible only option is polyamide. Why? Because polyamide has a very high boiling point. Why do we require a high boiling point polymer? Rest of the three do not have a considerably high boiling point. Boiling point high हमें इसीलिए चाहिए क्योंकि gas chromatography में the columns are maintained at a very high temperatures. So वो थर्मोस्टेट में रखा जाता है कॉलम्स को, और वो बहुत हाई टेम्परेचर में मेंटेन होता है. क्यों? ताकि सैंपल का गैसियस स्टेट मेंटेन रहे. अगर वो गैसियस स्टेट में मेंटेन नहीं रहेगा, so there is a possibility that your sample may condense inside the column and will not travel along with the gaseous mobile phase. So since हमारा mobile phase, that is the carrier mobile phase, is gas in gas chromatography, we require to maintain the column at a very high temperature. So for that, you will require a very high boiling point polymer. So all of these four options, the only high boiling point polymer is polyamide, and it is also waxy in nature and uniformly coats in the internal walls of the capillary column. So our answer is polyamide. So let us save and proceed with the next. Now we have the pumps for liquid chromatography should be able to generate pressure up to the following PSI. Option A is 1000, option 2 is 2000, option C is 6000, and option D is 10,000. This is a very instrumental aspect of the liquid chromatography instrument. तो 1000 pressure जो है वो बहुत ज़्यादा कम है. So 1000 and 2000 is less pressure. So that much pressure of the pump will not be able to provide the adequate volume of mobile phase to travel through your column. So the desired one that remains is 6000. Why? Because if the pump is having a pressure of 6000, it will be able to pump out that much of mobile phase from your mobile phase container, and it will help to travel and flow uniformly through the length of your column and help in eluting out the sample. Again, 10,000 is too much high pressure. Why? because if the mobile phase pressure is too high, there is a possibility of the column material being washed out. तो अगर बहुत ज़्यादा प्रेशर से तुम अगर मोबाइल फेस कॉलम में इनकॉर्पोरेट करोगे तो सिंस द स्टेशनरी फेसेस इज हैविंग सिलिका देयर कैन बी सरफेस एरोजन ऑफ द सिलिका so that is the reason why we will not use a very high pressure to incorporate the mobile phase in your column. So these columns are, but since it has to give you a high performance, you will need adequate pressure. क्योंकि अगर pressure बहुत ज़्यादा कम होगा तो it will lead to longer retention times. क्यों? क्योंकि mobile phase को ज़्यादा time लगेगा column equilibrate करने में और column के through गुजरने में और analyte को separate करने में. तो बहुत ज़्यादा कम pressure भी नहीं चाहिए और बहुत ज़्यादा pressure भी नहीं चाहिए. So the ideal pressure for the pumps used in liquid chromatography is 6,000. So the answer is 6,000. So we will proceed with this answer. So 1 and 2, option A and B is not our answer, and option D is pressure is too high, which can cause the damage of the column. So that will also not be our answer. So the only possible answer that remains is option C. Moving on to the next, the limit of detection, that is LOD, signal to noise ratio, is which of the following? Is it 2:1, 3:1, 8:1, or 10:1? Now, LOD means we have the lower limit of detection. Now, for the lower limit of detection, there is a hypothesis that has been done by various chromatographers and various analysts who have carried out the analysis. The LOD is the concentration at which the signal level of the substance reaches at least 3 times the signal noise of the baseline. So lower limit of detection, like you are able to, lower limit of detection means what? The minimal quantity or the minimal concentration of the sample which your detector or chromatography technique can detect. So that is called as the lower limit of detection. So it is only qualitative. तुम्हें सिर्फ वो signal को detect करना है. You don't have to quantify it. So that is the reason why it has to be, it is stated or hypothesized that it should be at least 3 times the signal noise of the baseline. Now, whenever a mobile phase is flowing through a column, वो अपना खुद का एक baseline produce करता है. So it is obviously, they will have multiple minor peaks. So when the mobile phase will flow through the column, you will get minute peaks along the line of the flow. You will never get a uniform straight line. तो अगर तुम्हारा सैंपल बहुत ज़्यादा कम concentration का है, तो usually वो तुम्हारा इंस्ट्रूमेंट उसको उस लेवल तक डिटेक्ट नहीं कर पाता and it get cancelled out along with the baseline of the mobile phase. So for it to be detected, it is necessary that the concentration should at least be 3 times the signal of the baseline. So only if the concentration is 3 times the signal noise of the baseline, then only will it be capable to be detected under the LOD concentration. So 2:1 is too less because there is a possibility that the 2:1 ratio, that means if your concentration is just twice the noise of the baseline, there is a possibility it will remain undetected. 3:1 is the ideal one. As I said, it is hypothesized that it has to be 3 times the noise of the signal. It cannot be 8:1. Why? Because 8:1 will give you a higher peak and the concentration will not be LOD, but it will go slightly above the LOD level. So LOD concentration, so वैसा concentration होता है जो सिर्फ capable होना चाहिए कि detect करे. 8:1 ratio क्या होगा? It will be capable to detect qualitatively as well as quantitatively. So 8:1 ratio is also not our answer. Also 10:1 ratio is basically usually the criteria for LOQ, that is lower limit of quantitation concentrations. So for lower limit of quantitation concentrations, it is highly likely that it will both get qualitatively analyzed as well as quantitatively analyzed. So it will not fall under the category of LOD. So our answer is also not 10:1. So our answer is 3:1 because why? The concentration has to be thrice the signal noise of the baseline. So signal noise will be usually in the ratio of 1 and 3 times of that signal noise should be the signal of our sample. Then only will it fall under the category of LOD. So that's our answer. Let us proceed. Stahl's triangle deals with one of the following, that is collection, as a selection of composition of stationary phase, selection of solvent, selection of the length of the column, and any of the above. Now, Stahl's triangle is a triangle that has been hypothesized by a scientist called as Stahl. तो उसने क्या किया था, उसने एक ट्रायंगल बनाया था और उससे it was found that an active adsorbent is required together along with a non-polar solvent. So mixtures of two or more solvents of different polarity often give better separation than chemically homogeneous solvents. तो इसका मतलब क्या थियरी बनता है कि उसने ये फाइंड आउट किया था कि जब तुम एक सिंगल सॉल्वेंट यूज करोगे एज अ मोबाइल फेस फॉर एनालिसिस then it is highly unlikely कि तुम्हारा सैंपल अच्छे से सेपरेट और इल्यूट होगा just by using one single solvent. So basically तुम मोबाइल फेस देखोगे they are mixture of multiple solvents, like you will have a mixture of methanol or acetonitrile and a mixture of buffer solution for HPLC. And if you're doing a paper chromatography, then you will have a mixture of other multiple solvents, like you may have N-hexane, you may have propanol, methanol, or a mixture of benzene for separation. So Stahl's triangle made this theorem for exclusively for your selection of solvent. तो कौन सा solvent लेना है, कौन से mixture में, कौन से ratio में लेना है, वो तुम्हें Stahl's triangle से पता चलता है. So option 1 is not our answer. Option C is not our answer. Why? Because Stahl's triangle will never help you to find out the length of the column. And option D is any of the above. It is not any of the above either. So the only possible answer is the selection of solvent. Because Stahl's triangle was basically designed to optimize the mobile phase for separation. So moving on to the next. In paper chromatography, that is PC, which method is used for multi-sample analysis? We have ascending chromatography, descending chromatography, circular chromatography, and all of the above. Now look at option A. Ascending chromatography में क्या होता है? जो तुम्हारा सैंपल है वो मोबाइल फेस के साथ पेपर के लेंथ के थ्रू ट्रैवल करता है in an ascending direction, that is from bottom to top. क्यों? क्योंकि बॉटम में तुम्हारा मोबाइल फेस रखा होता है. So that is why मोबाइल फेस ऊपर की तरफ ट्रैवल करता है और तुम्हारे सल्यूट को सेपरेट करता है. डिसेंडिंग क्रोमेटोग्राफी में क्या होता है? इट इज जस्ट अ रिवर्स ऑफ एसेंडिंग क्रोमेटोग्राफी. डिसेंडिंग क्रोमेटोग्राफी में मोबाइल फेस का फ्लो पेपर के ऊपर के हिस्से से होता है. सो दैट इज द रीजन व्हाई द स्पॉट्स फॉर द स्पॉट्स ऑफ योर सैंपल is obtained at the bottom, that is the receding side of the paper. So descending chromatography is also not your answer, because why? ये ascending और descending दोनों techniques single analyte के लिए ही होते हैं. Why? Because first you will use spot your unknown sample and you will spot your standard. दोनों के बीच में comparison होगा. So if your unknown sample is having the standard present in it, it will give you the same retention time as that of the standard. So here you can only analyze a single analyte. But if you have a circular paper chromatography, now a circular paper chromatography provides a wider surface area compared to ascending and descending chromatography technique. So when your stationary phase of paper chromatography, which is a paper, which is the stationary phase in this scenario, अगर circular होगा, तो multiple analysis is possible. Why? Because if you are spotting your sample in the center of the circle, so if there are multiple analytes, they will be separated along the various radiuses of your circle. So because it will give you multiple spots. So multiple spots अगर होगा तो circular paper में multiple spots को analyze करने के लिए easy होगा compared to that of a paper. I mean the rectangular paper. So circular chromatography में बीच में, that is the center of the circle, if you are spotting your sample and if your paper is moving in a circular motion clockwise or anti-clockwise along with the flow of the mobile phase, तो क्या होता है, that single mobile phase and that single paper, that is the circular paper, is able to analyze mixture of your analyte. मतलब तुमने भले ही तुम्हारे unknown sample में multiple analytes हो, वो सारे के सारे if you are using a proper mobile phase will be separated and you will be able to analyze. So the circular chromatography is the only technique in paper chromatography, which is also called as a radial chromatography for multiple sample analysis. So my option is circular chromatography. So let us proceed to the next. So now I have the next question, which is the element strength is a measure of what? Is it a solvent adsorption energy? Is it a solvent absorption energy? Or is it solvent diffusivity? Or is it option D, which is solvent mixing index? Now, what is solvent adsorption energy? क्या होता है solvent adsorption energy, which is our first option over here in this scenario. Eluent strength is a measure of the solvent adsorption energy only. Why? Because of the heliotropic series. So ranks of solvents have different capabilities to displace solutes from a given adsorbent. तो हर एक solvent के अलग-अलग कैपेसिटी होती है तुम्हारे सोल्यूट्स को सेपरेट करने के लिए. तो ऑब्वियसली इट हैज टू बी एडसॉर्प्शन. व्हाई? बिकॉज मोबाइल फेज, एज आई सेड, हैज टू एडसॉर्ब ऑन टू द स्टेशनरी फेज, एंड बिकॉज ऑफ दैट इट विल बी एबल टू डिसॉर्ब योर सैंपल. इफ इट हैज अफिनिटी फॉर द मोबाइल फेज, वो ट्रैवल करेगा मोबाइल फेज के साथ और वो इल्यूट होगा. इट कैन नॉट बी सॉल्वेंट एब्जॉर्प्शन एनर्जी, क्योंकि सॉल्वेंट को हम स्टेशनरी फेज पे एब्जॉर्ब करना हमारा गोल ही नहीं है. व्हाट डू वी हैव टू डू? वी हैव टू जस्ट पास द सॉल्वेंट थ्रू द मोबाइल फेज इन सच अ वे कि अगर कोई एनालाइट एब्जॉर्ब्ड होगा तुम्हारे स्टेशनरी फेज पे, तो वो इलेवेंट स्ट्रेंथ अगर उस सॉल्वेंट का ज्यादा होगा और अफिनिटी ज्यादा होगी एनालाइट के लिए, तो एनालाइट विल डिस्प्लेस फ्रॉम द सरफेस ऑफ द स्टेशनरी फेज एंड इट विल मूव अलोंग विद द फ्लो ऑफ द मोबाइल फेज. सो ऑप्शन बी इज ऑल्सो नॉट योर आंसर. सॉल्वेंट को डिफ्यूज भी नहीं करना है, इसलिए solvent diffusivity is also not our answer. And option D is the solvent mixing index. So it also does not measure the solvent mixing index. So it only measures the energy that the solvent requires to adsorb. So eluent strength is basically the measurement of the solvent adsorption energy. So the more polar the solvent, the greater is its eluent strength, and the more rapid will the solutes be eluted from your column. So solvent adsorption energy is our answer. Moving on to our last question, which is which of the following components cannot be retained by gas liquid columns but can be separated by using gas solid chromatography? We have option A, which is formaldehyde. We have option B, hydrogen sulfide. We have option C, benzene, and we have option D, carbon dioxide. Now, formaldehyde cannot be the answer. Why? Because formaldehyde can be retained using the gas liquid column, but it cannot be retained using a gas solid column. So for the gas solid column is only applicable for gaseous samples. So benzene and formaldehyde are both liquid in nature, and hence they do not have the property of being gaseous in nature. So that is why the only gases which are there among all the four options is hydrogen sulfide and carbon dioxide. Now carbon dioxide cannot be used in the GLC. Why? Because it gives you a background noise in the gas chromatography. So you have to, that is the reason why it is operated in वैक्यूम रीजन. तो गैस क्रोमेटोग्राफी जो टेक्निक होता है वो वैक्यूम में होता है. क्यों? क्योंकि सिर्फ तुम्हारा कैरियर गैस होना चाहिए उसमें. Air is a mixture of oxygen and carbon dioxide and other various gases. So those those components in the air will provide a hindrance or will interfere with the analysis of the sample. So the vacuum that is a vacuum housing which is there for the gas chromatography will only be able to supply the only gas, that is the carrier gas. So you already have a carrier gas which is your mobile phase. तो mobile phase जब है तो उसमें carbon dioxide is not a desired gas for analysis of gas chromatography. So carbon dioxide is eliminated as an option because it will give you unnecessary baseline noise. So the only gas or the which remains among all the four options to be separated using a gas solid chromatography is hydrogen sulfide. So H2S gas, that is hydrogen sulfide gas, can be analyzed using the gas solid chromatography. So that will be all for today. So I will submit the test. Yes, I will submit it. So I have attempted the test and I have scored the proper results. So I hope you will be able to approach the answers and how to give you the this will help you to solve the what you say, the MCQs that are going to be there in GPAT. Okay, GPAT may the only possible way you can quickly submit your paper is by eliminating the options which cannot be your answer. Then usually options जो होते हैं, they will usually have one or two options which are very closely related, and you will feel that that is your proper answer, but usually they are not. So that is how you will solve your answers. So I think I left one question unattempted, so maybe during the explanation I did not, I must have skipped it. So that is why I got a negative marking of 4. So otherwise I have a perfect score of 8. So that is all for today. So I hope you understood how to approach the questions properly. Thank you, that would be all. So let us end this session for today.